measurements are approximate. They're given to the nearest practical unit, like a centimetre, or a millimetre, or a gram, for example. There is then a group of numbers that the original measurement is somewhere between. This is called the limits of accuracy. There is a largest possible number called the upper bound and a lowest possible number called the lower bound. This baby weighs 7 kilograms to the nearest kilogram. What is the smallest possible weight the baby could be for us to round it up to 7 kilograms? The lower bound is 6.5 kilograms. Anything less than 6.5 would have been rounded down to 6. And so 6.5, 6.6, 6.7, etc. all round up to 7 kilograms. So what's the heaviest that the baby could be for it to round down to 7 kilograms? Do you agree that it is anything less than 7.5? So 7.49999 recurring. The 9s recur infinitely, and so we say it is equal to 7.5. So the upper bound is 7.5 kilograms. So the baby's weight is somewhere between 6.5 and 7.5 kilograms. We could write this as an inequality, like this. If you find it difficult to visualise what the upper and lower bounds are, then there's a really simple method that will help. Half the degree of accuracy and then add or subtract this from the rounded value to get the upper and lower bounds. So for our 7 kilogram baby to the nearest kilogram, the degree of accuracy is 1 kilogram. So half of this is 0.5. 7 kilograms add 0.5 is 7.5 kilograms for the upper bound, and 7 kilograms subtract 0.5 is 6.5 kilograms for the lower bound. So this method may come in handy when thinking about decimal places and significant figures. Give these questions a go. Pause the video, work out the answers and click play when you're ready. How did you do? What is the upper bound of 9.58 seconds to the nearest 0.01 seconds? It's exactly the same as asking 9.58 has been rounded to 2 decimal places. What is the upper bound? A lot of us find measures like time, weight, length easier to work with than decimal places and significant figures. But just do the same thing. Half the degree of accuracy and then add or subtract this from the rounded value. 2 decimal places is 0.01 accuracy. So half of this is 0.005. You just go 1 decimal place further along. So 9.58 plus 0.005 equals 9.585. Do the same thing for significant figures, half the degree of accuracy. So give this question a go. Pause the video, work out the answer and click play when you're ready. Did you get 72.75? For this question, 3 sig figs means we've rounded to 1 decimal place. So the degree of accuracy is 0.1. Half of 0.1 is 0.05, which we can then subtract. So give these questions a go. Pause the video, work them out and click play when you're ready. Did you get them right? So there we have bounds. Just remember to half the degree of accuracy and you'll have no problems. In part 2, we're going to look at how to calculate the bounds to get either the biggest possible or smallest possible answers.